Welcome to another part of the ISM Exercise Set Microeconomics, this time with a unit on Polypolies. Let's have a look at the exercise. Here we have a company produces chocolates. These chocolates or pralines can be sold on the market at a price of €5 per package. Internally, the company faces the following cost function. And we have here 0.05x squared plus 0.2 as fixed cost. Then our tasks for this: first, determine the profit maximizing output of the company. Second, calculate the profit of the company. Third, how many units will each company offer on the market in the long run and what price will the market settle down to. And finally, how many companies will be active on the market in the long run if the total market demand results from the following demand function. Demand function here being x being equal to minus 10p plus 18. Okay, before we can start with any of these four parts, we first have to do some small preliminary work. This means we need to calculate the average and the marginal costs. So let's just copy the cost function. And if we are asked about the marginal costs, that just means we calculate the first derivative of the cost function. So here, the first derivative, that's just 0.1x, that's it. Because the 0.2 is dropped as this is fixed cost and does not change. Okay, that's the first part. And the second part, as I said, the average cost. So to get the average cost, we simply divide the costs by the quantity produced. So we divide the costs by x. Then we have 0.05x, because x squared divided by x is x, and 0.2 divided by x. And well, that's all the preparatory work we need, because in the first part, when we're asked about the profit maximizing output, what we need is only the marginal costs. Because whenever you are tasked with getting profit maximizing outputs in a Polypolies situation, and there's nothing about long term in the task. We recall long term, that was only part C. Here there was nothing. And there's a price given to you, which here there actually is, of €5. Then you can simply set price equal to marginal costs. So that's what we're going to do here. We set price 5 equal to marginal costs 0.1x, and we solve for x simply by multiplying with 10, giving us here a profit maximizing output of 50. Perfect. Then we have price, we have quantity, so that means we have everything we need to calculate the profit. So to start with part B. Because the profit is determined as revenues minus costs, revenues being quantity times price. And the cost, well, we simply insert the quantity we have into our cost function. So then this looks as follows, with 5 times 50 revenues minus, then we insert, as I said, the 50 into the cost function, so 0.05 times 50 squared, so 2,500, plus 0.2, giving a total profit of 124.8. And well, that's then all there is to part B. And we can turn to the long-term equilibrium. As I said before, whenever you read nothing with long-term, that's usually price equals marginal cost. Whenever you read something about long-term equilibrium, long-term solution, this means you equalize marginal costs and average costs. So that's what we're going to do here. Average cost, that was 0.05x plus 0.2 divided by x. Marginal cost 0.1x. So we solve this for x by first subtracting 0.05x, then multiplying with x. This then looks as 0.05x squared equal to 0.2. Okay, we need to get rid of the 0.05. So either we multiply all of this with 20 or divide by 0.05. Then, well, if we multiply with 20, we have on the right side 4, and we take the square root of the 4, leaving us with x being equal to 2. So in the long term, we only will have a production of 2 as profit maximizing. And if we insert this quantity into either the average or the marginal cost, usually it's easier to go with the marginal costs, we will have here a price of 0.1 times 2, so of 0.2. And well, if we recall, before the price was at 5 euros. Now it's at 20 cents. So the price dropped. Actually, the quantity also dropped. And that's always the situation when you have a positive profit. So if you are tasked first with calculating the profit and then in some way the long-term equilibrium, you can always be assured if the profit is positive, the prices and the quantity will drop. If the profit is negative, quantity and prices will increase. Well, that's all there is to the part C, with the additional comment on how to check whether we did this more or less correctly. So we're only stuck with the last part, finding out how many companies will establish themselves in the long term. For this, we need to first get our total market demand. So how much do the customers want of the chocolates if the price is at 20 cents? And well, we get this by simply inserting the P equals to 0.2 into our demand function. So we set the demand, or we get the demand at a price of 20 cents by inserting this. Then we have X being equal to 18 minus 10 times 0.2. So we get here a total market demand of 16. Okay, all the customers want to have 16. Every company produces 2, or each company produces 2. So we can get the number of companies by dividing the overall market demand, the total market demand, by the production per company. So we divide the 16 by the 2. And this leaves us with a total number of companies, being 8, that will establish themselves in the long term. And maybe it could be that you get an additional task. Here it's not the case, where you're asked about the long-term profits of each company. And well, that's like a trick question, because in the long term, profits will always be 0. That's also why we know that the long term profits will decrease, prices will decrease. Okay, so this as a final remark, and I hope you enjoyed listening to it so far. And if you're interested in seeing more exercises, feel free to visit the rest of the exercise set or have a look at the corresponding playlist. I say goodbye and see you next time.